Hello, let me introduce to you the navigation possibilities of SpaceCrafter 2023 Pro. If you press the V key, you will get the date and time. But if you press Windows N, you will activate the navigation mode. In this mode, you have a lot of data that we have to discuss now. You still have the date and time of today in your time zone. As we are in daylight saving period and Central Europe time, there's 2 hours difference with the universal time clock. So there's 2 hours of difference between these two clocks. As you can see, you get also the Greenwich sidereal time. How to know the difference between the universal time and the Greenwich sidereal time? To point out that, we need to activate by pressing Shift+C and you will get a line. This line symbolizes the Greenwich meridian. You can draw your meridian line by pressing X. If I press C, I will get the equatorial grid with coordinates written in degrees. To get them back to normal, you have to cancel the Windows navigation mode. In this case, you will get the right ascension values, but then we miss the other clocks. If you press Ctrl+N, you will get the astronomical mode. This mode will be useful for our explanations now. Here you have the Greenwich meridian line. The coordinates in right ascension is 11 past 36 minutes. As you can see, for us it's close to 12. And if you read the local sidereal time, you will get something close to 12. And if I move it a little bit, I will then have 12 o'clock on our meridian line. Then, as you can see, the meridian line is identical to 12 hours for the right ascension. So, we have managed to figure out what it means. Now the Greenwich sidereal time is what stands for this red line, and the universal time has a difference of 2 hours from our clock. But as you can see, the Greenwich sidereal time and the universal time is quite different, and this difference can be explained because of the sun position. So if we get back the sun at midday, using the J and L keys and stop with the key K, you have the sun centered to the meridian. You get then for the local civilian time 12 o'clock, but not quite well. If we change time a little bit to center the clock at 12 o'clock, you will not have exactly the sun positioned there. But if you press the Y button, you will notice that the analemma will be centered because of the equation of time. The local civilian time is a mean time through the year, not considering the equation of time. You can get some other informations as well. If we accelerate the time, we'll shift the analemma. We can press as well Shift+Y and you will get the analemma centered to the meridian line. It can be useful for some explanations. You can get as well the equator, but the equator is superimposed to the equatorial grid. We give away the equatorial grid and then we can add some smart lines by pressing second and D. That way, we have the tropic lines. Those lines can be useful to mark the path of the sun through the entire year. The second line contains the latitude and longitude. It can be drawn in the normal mode by pressing Ctrl+V. You get as well the equation of time, so the difference in position of the sun compared to the mean time. The Greenwich meridian pass, which is now 12 hours 1 minute and 54 seconds. IIT correspond to midday plus the equation of time. The time local pass is 11 hours and 40 minutes. If you go to 11:40 precisely, you will notice that at 11 hours 40 minutes universal time, you will get the sun crossing the meridian line at your local position. At which time on the universal clock you get the sun crossing the meridian. Now if we go to nighttime and select, for example, the moon, and why not selecting Antares? After having selected those two, you can press second and then angular distance. That way you've got the angular value between Antares and the moon. But if you decide to jump to the next day, Ctrl+1 day to get Julian day, or with O only, you get a sidereal day. Which is better because the stars won't move when you press O repeatedly. You'll get another value for the angular distance because the moon has moved on its course around the Earth. It's dynamical and pretty interesting to get those informations. You can have other informations that can be useful as well. For example, if you press Windows+N or this key at the right position of L, because M is only available to this position on French keyboards, you can have informations about your pointer position. By pressing Windows plus V you will get those information attached to the selected object. So if the time is running, by pressing V to get the time and accelerating the time flow with L you will get the sky movement. Then, the azimuth and altitude are moving, as well as the right ascension and declination informations, but changing slowly. By pressing Shift plus H, you've got a line that has appeared passing through the position of your selected object and the north celestial pole. This will give you data about declination of the selected object. By pressing Windows plus H, you've got something more related to azimuth and altitude of this object. If you press the X key you will get the meridian as well. That way you have built the complete nautical triangle passing by the zenith that you can draw by pressing second followed by Z. You can see it there. We will give up the angular distance that we don't need anymore. If you accelerate time by pressing the L key many times, you'll get the triangle evolving through time. Of course you can select another object and get the same result with Jupiter, with Saturn, and so on. Now we will go through another function that is quite interesting, dealing with the sun, and for our example I will need to have the moon visible as well. Okay, imagine you have the sun, you have the moon, and you don't know where you are, you have just the sea all around you. This is a quite useful landscape because this landscape permits you to get the sea level at 0. But there are also the 6 degrees under sea level circle, the 12 degrees circle, and the 18 degrees circle. Those circles corresponding of the sunset, the civilian twilight, the nautical twilight, and then the astronomical twilight. When the height of the sun comes to these values under the horizon, we will go back to normal view by pressing the zoom minus key that permits to get the complete view of the horizon. And we go back to normal view mode with zenith centered on the dome. You have to determine the height of those two bodies. You can use for that as sextant. I will explain some scripts about this later. For now, we have to determine the height of the moon and the height of the sun. To make it easy for your audience, I suggest to use the key second followed by the meridian line which correspond to the X key. Then you can identify quite easily the height of the sun and the height of the moon. By pressing Windows H, you get the azimuthal line to read a more precise value. You can use the azimuthal grid as well, and with those estimations you can have the value for the moon as well. You can use Windows and right-click also if you put the mouse where the body is. The altitude is 21 degrees and a half for the moon, and for the sun you can get the approximate altitude. If you want to get a more precise value, you have to notice that if you select for example the sun and you press second followed by V you will get some data. But if you are in the Windows navigation mode you will get more data like the right ascension and declination and the co-altitude and some other informations. So if we go to Inversarium, which is located there. If you enter this mode you will switch from the normal mode with the sky to the map mode. With the map mode you will get the sky but in left-right reverse drawing. The world will be drawn in normal view, even if the curvature is reversed. You can recognize all the continents easily. If you click on this button you will get at which vertical position the sun is located. Right above us at zenith when we are at this place on Earth. You have to be in Africa now and here to see the sun right above you. The moon is at north of Madagascar. If you are here at this moment you will get the moon very high in the sky. The same for the planets, the bright dots that appeared too. So if you use the information we got from the moon altitude it was something like 21 degrees. But we need the co-altitude to build a circle centered on the moon. As you may know, imagine that the moon is right above your head. You can get this information from almanacs and ephemeris of the position of the different bodies in the sky at some moments. You have to compute to interpolate to your precise date and time. You can determine the position where people can see the moon right above their heads. Imagine that you don't see it right above you but at 10 degrees from the zenith. Then you should be located somewhere around this position. As we saw the moon at 21 degrees, the co-altitude is 90-21, that makes 69 degrees. And you have to draw a circle centered on the moon with 69 degrees of radius. That way you can say that you are somewhere on this circle. Okay, now with the sun. you do it the same way. We saw it further away from the zenith compared to the moon, but something like 30 degrees. We were close to noon in Europe, and that way you will have two intersections with the two circles. Well, with that two positions, you should be knowing precisely where you are, in what sea you are. Not in Atlantic and probably close to Marseille, where I live and where I had began with my positioning. So that way you can now determine where you are by using the height of two bodies. Most of the time people uses the sun only at two different times. That way, they got the possibility to get two circles and then determine their position. Of course you can do it by night and then use the planets or use a star. Even if it's more complicated, as stars are fainter. You've got the Polaris star for example. The Polaris star is located at less than 1 degree around the North Pole. In south of France, its height is 43 degrees above the north horizon. It corresponds to the latitude of Marseille. So you'll have a circle centered to approximately the North Pole and with a radius of 90-43, that is 47 degrees. So that way you determine precisely that you're not in the Atlantic Ocean but in the Mediterranean Sea. When you are in navigation mode, you don't get this landscape, which is the observatory by default. If you press second and this key, you will get water all around you. As you can see, the water is higher than the zero level, but it's because the landscape has been saved with a field of view of 190. To be sure, if you press second followed by X, you will see that zero will be at the sea level. So you are exactly seeing things at their right place. And if you want to see everything above zero at its real height, the zero located at the horizon, you can press the zoom out key. That way you will get what you want. But sometimes it's better to get the sea level visible to make the immersive feeling of being on high seas. That's when you press second and the key located at right position of left shift. If you press shift and the same key, you will get another landscape. If you press Ctrl plus W or Z, if you use a QWERTY keyboard, you'll get another landscape. With Ctrl plus the key at right of left shift, you will have a menu that will provide a buoy located somewhere on Earth. If you use the joypad, you can change of latitude by moving the right stick up and down. If I push it down or up, it'll change the latitude. And you will get landscapes corresponding to where the buoy is. Here you've got a Sydney landscape. You will get a polar landscape when you are close to South Pole or North Pole. So it can be interesting to have the change on landscape automatically. You can hide the landscape with the red B button. You can hide or see the globe by pressing the LB or RB triggers. I was missing Ctrl plus W or Z key. If you press it, you will get a very useful landscape. With the sea level at zero and nothing above. And the circles making the sun appear with transparency under 6, 12 and 18 degrees under the horizon. That stands for civilian, nautical and astronomical twilight. Okay, let's go to Windows key associations. By pressing Windows plus this key, you will get another interactive script using the joypad permitting to navigate from your position that you can see here. For me it's in Marseille at the beginning and you can navigate with the right stick of the joypad. It makes you change your latitude and longitude. By using the directional cross named hat on your joypad, you can center the cursor. If you press the red button, you will leave the script and get the proper landscape. Scripts like these can't be stopped by resetting the software. You have to press the G key to discard all and stop any running loop. If you experience some trouble, do that followed by End or Home to get back all the controls and no residual options drawn at screen. We will see now the different Milky Ways we have with spacecraft navigation. If you press the 0 of the numeric pad key, you will get back to the normal Milky Way. But by pressing the 1 key, you will get the sea currents on an Earth map. By pressing 2, you'll get largest currents and you can have a wider look at the map with page down if I use this positioning with the mouse for example. By pressing 3, you will get the different time zones. By pressing 4 on the numeric pad, you will get the winds on Earth at different temperatures. The cold winds in blue and the hot winds in red. By pressing 5, you will get the different rifts and altimetry.
White is meaning high altitude, and then red, orange, yellow, green, clear blue and dark blue for the lowest zones.
With 6, you will get an Earth map with water filling the oceans. With the key 7, you'll get other informations concerning the temperatures. With 8, you will get what you have in normal mode concerning the sky figures from Solarius. With 9, you will get the night zones on Earth. With dot you will get the intensity of the magnetic field of Earth. Now we will switch to second followed by the same keys. With second and 0 on the numeric pad, you will get the different navigator trips around the oceans. With second and 1 you will get an ancient map. With second and 2, you will get the tropic zones and the polar circle zones delimitations. With second and 3 you will get something close to what you did get with 3. It's the time zones, but with different colors and informations. With second and 4, you will get the different gravitational anomalies on Earth's surface. With second and 5 you will get the different continental plates on Earth. With second and 6, you will get what you had on the normal map. It's something similar to 5 key but with different colors. With second and 7 you will get an ancient map as well. With second and 8, it is similar to normal mode. It's the Solarius Christian sky culture. With second and 9, you will get another ancient map. And with second followed by it, you will get the last one, another ancient map.
Now we will investigate the Control plus function keys associated to scripts.
Control plus F1 will put you to what we call the refraction interactive script.
Within this script, you can see the sun and all the controls are like all other interactive scripts done with the joypad. If you press continuously the LB or RB buttons you will go back or forth in time. You have a clear white sun visible. If you look closer by zooming to the sun position, you will see A with circle at the right position of the sun. The sun will be placed as it is visible at this moment due to the refraction of the atmosphere with a reddish color. That way you can simulate the refraction and the corresponding true sun without atmosphere compared with the visible sun. We enlarged the size of the sun by zooming, but it's not its real size. The aspect of the sun has been enlarged 4 times compared to normal. It has been done to clearly view the effect of the refraction. The difference in position has been enlarged the same way to match the real aspect.
It's like if you were viewing it through some binoculars.
Okay, that's all for the first script.
Let's stop it by pressing the G key. Let's go back to normal mode, then navigation mode. And now with Control plus F2. Control plus F2 is launching the view of the motions of stars. As you can see, we have discarded the atmosphere. And it's a Milky Way skin that makes visible the trajectories of the stars due to the Earth's rotation. We see clearly where the stars located at distinct declinations are setting. It can be used with the azimuthal ruler as a landscape. To locate at which declination we get circumpolar stars. Control plus F3 will bring a fully functional Nachterlebe. You must see the Polaris star through the central hole. You need to put the 2 stars W and Merak aligned with the front ruler when at the same time maintaining the Nachterlebe vertically. You can change the orientation of the middle disk to correspond to the date of today. You can move the disk by pressing Control 2 or Control 8 from the numeric pad to navigating in one way or the other. And if you press Control 4 or 6, you will navigate the ruler to make it correspond to W and Merak. The ruler will now indicate the time of your clock. If it doesn't match, you have to set the primary disk orientation to your location. You have to enter the source code of the program to set precisely the orientation of the disk corresponding where you are located. You have to press Alt plus F3 to open Thunar file browser. Then you go to Scripts folder, then Navigation folder, and then F-Scripts folder. It's located to the third script named 03.sts because we pressed Control plus F3. Control plus F1 is associated to 01.sts at Katara. If you click on the 03.sts, you'll view the code of the script, which is quite simple but powerful. You have to locate the first disk. It's named N0. Here it is. The longitude is corresponding to Marseille.
You have to set by try and errors to get the proper value corresponding to your position. Concerning the height, you have an altitude here, and the altitude obviously is set to match with your own latitude, and this one, rotation, is related to your longitude. You have to modify it a little bit knowing that this value is corresponding to Marseille. If you are, I would say, 1 degree east of Marseille, you will have to indicate -113 or -115. I don't know exactly if it moves in one way or the other. Now we will launch the Ctrl plus F4 script. The one associated to Ctrl plus F4 is a very simple script as well. But this script is providing here what we call the medium sun. This sun is located precisely on the equator. This is a medium sun because of its movement through the year. It's like if the sun was at the equator and the Earth had a perfectly circular movement around it. This sun appears at the center of the analemma and positioned on the equator. It's linked to the local civil time. Now Ctrl plus F5. In this case we will get the different seasons, and it's identical to normal mode. The movement of the sun at different seasons beginning at sunrise, stopping at midday and finishing at sunset. Let's now go to Ctrl plus F6. You will get at first a landscape. You can talk about the use of a sextant. But all is automatic. It's not interactive like the interactive sextant script. Ctrl plus F7. You've got different wind roses one after the other by pressing K. You can stop at the one you want and get back all the controls by pressing the G key. Some are calculated for different locations on Earth. The source of the script is 07.sts. For Ctrl plus F8, you will get some azimuthal grids of different kind. You press K to change the grid and stop at the one you want to use with G. Ctrl plus F9. You will be able to talk about the tidal waves. With only Earth gravity, you would get no tides at all. But due to the fact that we have the moon, the different distance to the moon from distinct points on Earth, you'll get different forces. The water located behind will be less attracted by the moon compared to the water that is in front of the moon. The middle of the Earth is attracted with a mean force. That way you get two tides apart from the Earth, which is a solid and moves as a block. But there's not only the moon tides. There are also the sun tides that are represented here. You get two other tides. Those are 2 times less efficient than the moon tides. Tides due to the moon and tides from the sun can superimpose. There's also indications about the amplitude of the tides due to the position of the sun and the moon on the ecliptic, influencing more if closer to the equator or not. You've got higher tides due to the more efficient impact on the Earth's surface. Now with Ctrl plus F10. Let's talk about the loxodromy and orthodromy with this script named Cities on Map. This script provides many locations on Earth to deal with. There are plenty of towns recorded in the script. But you can add yours as you like by editing the script. To give an example, let's go to Paris and go somewhere else on Earth. We select Paris, then we select for example Papeete, which is located in the French Polynesia island named Tahiti. Now we activate by pressing second and I key, which correspond to orthodromy. As you can see, the path is going through Greenland and close to Los Angeles. Los Angeles is the stopover when you go by plane from Paris to Papeete by plane. As you may know, it's the best route. By pressing second and U, which correspond to loxodromy, you will get another path. This path is corresponding to a trip from Paris to Papeete but with keeping a constant azimuth. That way it will send you to the South Pole if you continue your trip. If you select the path from Paris to Reykjavik, you will end at the North Pole instead of the South Pole. As you can see, the blue path is shorter than the red path. Orthodromy is better than loxodromy, even if loxodromy seems simpler to follow. You will get the distance in nautical miles along the two paths. You can add your own ports to navigate from one place to the other. Ctrl plus F11. You've got a little script permitting to deal with the nautical triangle. With the different coordinates grids and the 3 summits of the triangle. These summits are the zenith, the pole, and the star you want to calculate the height and the azimuth. That way, we built the nautical triangle.
Ctrl plus F12 will bring you a 3D octant that you can manipulate to focus on different elements.
You can discuss about the mirrors, the filters, and how to use it.
With Ctrl plus F13, well, as F13 is not existing, in fact it's Ctrl plus 1.
Because Ctrl plus F1 to F12 is existing, Ctrl plus F13, 14, 15, 16, 17, 18 are similar to Ctrl plus 1, 2, 3, 4, 5, 6 from the top of the keyboard. Beware, it's not those keys on the numeric pad. That way when pressing Ctrl plus 1, you will get something but you don't see it from there. You have to put off the landscape and the atmosphere to see them. That way if you go in the southern hemisphere, you will get the fishes from the austral part of the sky. When pressing the key K, you will get the different birds and animals that have been discovered in the southern countries. Then you'll get instruments dedicated to navigation and then the different discoveries or inventions of the period of discoveries made by boats around the Earth that we call the Age of Enlightenment. Now we will investigate Ctrl plus 2.
Doing so, you'll get the vertical line and the meridian.
By pressing K, you will switch to different other compasses that can be handful. You can stop at the one you need by pressing G, and that way you'll get back all the controls. With Ctrl plus 3, you get a map, and this map is an ancient map of the known Earth at this epoch. If you press Ctrl plus divide and multiply on the numeric pad, you will navigate through time.
It's an old version of the interactive script when we didn't control joypads. You can talk about the knowledge about the continents during the ancient times.
With the mouse you can center them to see all the known countries. At some epoch, the discovery of the new continent.
You can zoom out if you want to get the map in its entirety to get a field of view larger than 180 degrees. Now let's go to Ctrl plus 4. It'll draw the Greenwich meridian and you can see it's midday.
But if you are somewhere else at the same hour, the difference in right ascension will determine your longitude. It's a way to calculate it, knowing the time at Greenwich.
It's the origin, 0, of the longitudes.
With the sun and the moon you can get something similar to the inversarium but in a fixed way, as you can't change of positioning. You have two sets of examples within the navigation package of MasterPut.
With Ctrl plus 5, you will get a clock. The clock is pointing the star W. It's a way to make a clock with W to determine the time. Because the star is making a turn in 23 hours and 56 minutes. So, it's close to 24 hours and it can be used during nighttime, when you see it, to determine the time. In fact, it's a close ancestor of the Nocturlabe. With Ctrl plus 6, you will get the interactive sextant. The scripts named that way are scripts using the joypad. You have to use a joypad that get different parts. The left analog stick, the right analog stick, a digital cross named hat, and you've got 7 buttons and 4 triggers. The upper trigger are just buttons named LB and RB. The bottom triggers, named LT and RT, are analog triggers. That way if you press them smoothly or forcefully you will get a dynamical action. This script don't use analog movements anyway. It's used for stellar navigation or planetary navigation to change altitude most of the time. RB and LB will be used, as well as the red button named B on the Spock's controller. You will get a center view of what the telescope sees. The lateral views are the view of the sextant itself. So if you press the B button, it says to point the sextant to the horizon. By pressing the red button B, it says press clamp to release index bar. By clicking on the red button, it releases the index and you have to bring, by manipulating the lever, the sun to the right side of the view. That way we can go through the right stick and move the sextant arm to get the proper result. Once you have the sun at the horizon, we can press the red button again. Then we bring the sun to the horizon as precisely as possible. Let's swing to verify. If you push the right stick to the left and to the right, you'll see the sun tangential to the horizon and it validates the process. After that, we just have to read the angle on the sextant. We have now followed all the steps to use the sextant. We will now end our presentation with the full dome videos. Those can be called with the function keys. The first one, the F1 video, will show you boats coming to the shore. And as you can see, the closer the boats are, the more you see the hull of the boat.
But with faraway boats you just see the sails of the boat until it comes closer to
something like 5 kilometers. The F2 video is showing an astrolabe with Hipparchos statue to talk about those ancient instruments. F3 will show you the Endeavour, the boat that Captain Cook used to go back to Australia. And also the shore in Australia where he came back during his second trip. With F4 you will get Christopher Columbus' trip to the New World with 3 boats named Nina, Pinta, and Santa Maria. Only 2 boats came back, but they couldn't calculate precisely the latitude. When they arrived to the coasts of Portugal, they knew that they had to go down to get back home in Barcelona. But if he decided to go back to where the fort was implanted in the New World, they will have trouble because of the problem of the imprecise latitude. With F5 you get a Davis quadrant. With F6 you get an astrolabe with the different pieces shown separately and the construction of the different elements of the astrolabe. With F8 you have the Magellan Trip. It represents the first complete navigation around the world with the different troubles they encountered during the trip. With F9 you get an hourglass. With F10 you have an octant. With F11 you have a lunar eclipse with the moon that changes of color. With F12 you have the principle of the height circle with the different circles that we explained with the inversarium already, but here in video format. Now we will describe the function videos with the second key pressed just before. It permits to get 12 more videos using second with F1 for example. In this case you will get why we are sure that the Earth is round. Second followed by F2, you have the use of a navigation astrolabe used by 3 people explaining how they used it. Second and F3 will bring you an animation about the Meridian telescope. Second and F4 will bring you the Endeavour ship with Captain Cook using an octant. With second F5 you have how to use the Davis quadrant. With second F6, you've got how to determine the place you are due to the direction of the sun and the correction made by the circle of height on a map. With second F7 you have an animation to talk about the clocks that were used at this moment but not usable on a boat, so the invention of the marine chronograph was needed. Second F9 will bring you a way to determine the speed of your boat in knots. With second and F10 you have a sextant. With second and F11 you have the determination of obliquity of ecliptic by Pythias 23 centuries ago. Second and F12 will bring you the GPS and the position determination using a 3D height circle. And that will end our presentation.